Hi, welcome back to video number 5 of the series on forces. In the previous video, we were just talking about magnitude and resultant force, actually magnitude of resultant force and also stating the direction of the resultant force. If this is your very first time coming across this channel, please give me a subscribe. Just click on the subscribe button and also click on the notification bell so that you receive notifications when I post these videos. Okay, so if again, this is your first time. If not watch the previous video, just click up there. I think there should be a card over there that will link you to the previous video. In today's lesson, we're not really going to do anything new. It's going to be the old things, but this time it's just that we're going to solve past questions. So we're now going to apply everything that we've learned so far to solve one or two past questions if time will permit. Okay, so the very first question we're going to solve, all these questions are from Cambridge CAIE examination and it's mechanics paper. So yeah, this is the very first question. I didn't bring the year. I think next time I'll do better. I'll also add the year to it. But for the meantime, there's a question under forces and it's for 6 good marks. And 6 marks is just 12% of your total score. So if you can just go through with it successfully, you can see that you get cool 12% of the total score with no stress at all. Okay, so this is the force diagram. The question reads, 4 coplanar forces, which means that the forces are acting the same plane, act at a point. The magnitude of the forces are 5 newtons, 4 newtons, 3 newtons, and 7 newtons. And the direction in which the forces act are shown in the diagram. Good. Find the magnitude and the direction of the resultant force of the 4 forces. Now, just like we've been doing, we're going to break these forces into components. I'm going to break the 7 Newton force into its components parts. Let me just use the black and different arrows. So if I'm to complete this force diagram, there is going to be a force in this direction, that is, we're starting from this side and ending at the side. So there'll be a force to the left and a force to the right. Okay. Similarly, if I'm to break the 3 Newton force, let me use a different ink for that one. Breaking up the 3 Newton force, there is going to be a force again to the left, which is indicated with the the red arrow, and the force the bottom. We went through this, I think, in video number 2 or so. So check lesson number 2 if you don't, lesson number 1 or lesson number 2 to get clarification on this. So these are the two forces that are inclined at an angle. The 5 Newton force and the 4 Newton force, they are not really inclined at any angle. This is lying exactly on the horizontal axis and this is lying exactly on the vertical axis. So I'm not going to really worry myself about that. Now, getting into the solving process of this question, we're saying that resultant in the x direction basically is forces to the right minus forces to the left. Now we're going to ask ourselves very simple questions. How many forces are in the x direction? In this case, I think there are 3 forces. One force from the 5 Newton force, so there's a 5 Newton force, and one from the 7 Newton force, and don't forget there is an additional force from the 3 Newton force. So in total, I can say that there are 3 forces in the x direction. 2 are in the left and 1 to the right. So we can use this information to get something to do with this. Now the first one we're going to talk about is the force to the right. The force to the right is just 5 newtons, so we're not going to do anything about it, minus the sum of all forces to the left. Now the very first force to the left, let's say the 7 Newton force. Because the 7 Newton force, the x component of that force is adjacent to the angle. Again, we went through this one. We're going to use the cosine, the 7 Newton force and the cosine of the angle. In this case, the angle is 60 degrees. So that is going to be give me 7 cos 60. From there, we also move on to the next force moving in the same direction. In this case, the 3 Newton force. And again, it's adjacent to the side we're looking for. So it goes with the same thing. So plus 3 cos 30. Please, you have to be very careful at this stage. A lot of students tend to miss out the force over there, saying they kind of like lying on the same line. So be very, very careful. There are 3 forces over there. So Just take your time so that you don't miss out on any of the forces. Okay, good. So from there, we just type everything on the calculator. 5 minus the sum of all the forces, 7 cos 60, plus 3 cos 30. Okay, so that will give you, let me give an approximated value. There's negative 1.098. So negative 1.098. This is a resultant in the x direction. We're going to do the same thing for resultants in the y direction. But we know resultants in the y direction is forces to the top minus forces to the bottom, upward forces minus downward forces. Again, in this case, we've got two forces moving in downward direction, this force moving upwards. So we've got three forces, two moving downwards and one moving upwards. So let's do justice to this. Again, we start with the upward force, and the side that we're looking for, the vertical component, faces the angle directly. So you can see that there it faces the angle directly. So we know that if it faces the angle directly, we go with the sine. Again, this gives me 7 sine of the angle under consideration, sine 60, minus the sum of all the downward forces. Again, there's 3 Newton force and it's directly facing the angle 30 degrees. So this becomes 3 sine of 30 plus this, there is no angle of inclination. This pointing directly downwards. So this becomes plus 4. Again, we call on the calculator and type everything over there and we are good to go. So there's 7 sine 60 minus brackets open 3 sine 30 plus 4. Okay, so if everything is correct, yeah, this will give us 0.6212. Sorry, 0.5622. 0. What is wrong with me? 0.5. Let's confirm again. 5622. So there's a resultant in y direction. The question never said we should find resultants in x and resultants in y, but you need to do this to get 1 or 2 marks over there. We're told to find the magnitude and the direction of the resultant force. Now, from memory, the last time we did this, if you remember, we said that the magnitude of the resultant force is given by the squared of each component. So the resultant in x squared plus the resultant in y squared. That's the same thing we're going to do over there. So there's the square root of, don't mind my square root, it's still a square root. So there's going to be equal to negative 1.098 squared plus 0.5622 squared. In the previous video, I also told you to ignore the negatives when you are working. It makes your life easier. But if you are very strong with trigonometry, you can go ahead and work with the negatives. With the magnitude, it doesn't really change anything because it's going to be squared anyway. So there's the square root of 1.098 squared plus 0.5622 squared. And this gives me 1.23 to 36 figures. So there's 1.23 newtons. Now, after getting the magnitude of the resultant force, we're also told to find the direction of the resultant force. And the previous video, we were talking about a lot of things, especially going through the direction aspect. We said that we first need to get a diagram. We need to select angle placement, and we use the keywords clockwise or anti-clockwise to describe our angle to get our direction. So we're going to do the same thing over there. First, let me get my Cartesian plane. So don't mind my Cartesian plane. There's my Cartesian plane. And the x component is negative and the y is positive. X is negative, y is positive. So it should be in the second quadrant. So x is negative, y is positive. Good. The angle placement, I would like to put my angle to the x-axis. Okay. Now, I'm going to describe my angle from this x-axis. So if I'm going to describe from the x-axis, it means the arrow goes towards the side. and this arrow is moving in the direction of a clock, so it's clockwise. That's the first thing we need to do. The next thing is to represent our values over there. In this case, for the x component, we got 1.098. Like I said, I'm dropping the negative 0.98, and the y component is 0.5622. Now you can decide not to drop the negative. You're going to get the same answer, but like I said, your trigonometry should be very strong. In this case, you should be ready to deal with negative angles. So if you don't want to deal with any negative angles, that is, you're going to do the angular measurement from the positive x-axis in a clockwise direction. Just ignore the negatives and work with this one to be better for you. Okay, so finding angle theta, I can say that tan theta is going to be equal to opposite over adjacent. In this case, it's going to 0.5622 over the adjacent, which is 1.098. So getting this, I can say that theta is going to be equal to the arctan of, or tan inverse of 0.5622 over 1.098. Okay, so theta in this case is going to be equal to, let's call in the calculator again. So tan inverse of 0.5622 divided by 1.098, and this gives me 27.1 degrees. 27.1 degrees. By writing this is not the description of the wasn't in the direction. We need to give a clear description of the direction. You just can't write this and expect to get our full mark over there. For the magnitude, it's okay, but the direction you need to describe. So like I said, first we need to draw a diagram. We are done with that. Select angle placement. We're done with that. We find the angle. Now we use the keywords to describe it. Now you're seeing that the direction, in this case, the direction is 27.1 degrees. Now we're starting from the negative x-axis to the resultant force. So in this case, we are moving in the clockwise direction. So there is 27.1 degrees clockwise from the negative x-axis. And that is the full description of the question. You do this and it just gets the maximum mark of 6 points, which is, in my view, I think it's actually very easy to get it. So this is the very first example on the a very first past question example on the magnitude and direction of the resultant force. Now, in the next video, in video number, is it 5 or 6? I think this is the fifth one. So video number 6, we're going to talk about this very example. So check out this example, and when we meet some other time, we're going to talk about this one as well. Bye for now.